Alright, time for another draftphysics.com, debatephysics.com, also video presentation. So I found a couple of these horrible, great courses, videos, one on gravity and one on quantum mechanics. And this quantum mechanics one especially is just so full of lies and distortions and perversions. It's not even close to an accurate description of what actually happened and what actually has something to do with physics and drawing conclusions and evidence, and it's just so bad. It's just propaganda. And I'd argue it's got some sort of religious bent. You can sort of see from this little, whatever this icon is, this little eternal flame, They have great courses on finding Jesus, It does lots of different subjects, not just physics, and the physics has been watered down into, common denominator, psychobabble religion. Frankly, that's all it is, just religion. And so for the people arguing it's not a religion, this proves it's just a religion. So Dr. Lincoln is involved in this one. Sean Carroll does some yammering on the gravity subject. So they've all been paid, to just talk this shit. And they don't care about the truth, or they don't care about science. They think they have found the truth and their truth is satisfactory, and it's just what Bohr said. This video ends with a quote from Bohr saying, "Don't tell God what to do." So that's their whole attitude. They've decided it's it's this pervertiverse, this fun, silly-averse, and they're happy with that. Comforts them. So it's called Wonderum. Who does this? Who could that appeal to? What kind of person with any kind of integrity as a thinker be impressed by something called Wonderum? Ew. You just, on its face, it's just saying to you, bullshit.
Light is everywhere.
So I don't know who this guy is, but you're saying, okay, they couldn't find Mr. Charisma. He was busy this day. So they settled on this guy to introduce the video. So I don't even know what that is. He's probably a shareholder in some respect or another. Blah, blah, blah. But you do wonder.
It allows us to interpret the world around us and is a crucial requirement for life on Earth. But what?
La-di-da-di-da-di. Says you what's crucial. What's crucial for intelligent life on Earth is bullshit. Okay? You have to fool them. You have to break the logic and the intelligence to make any of this horseshit, this let's love the meat grinder bullshit, to make any sense at all.
Is light. This is
Look, the end of their quantum mechanics is also the statement that there is no determinism. So they're basically free willing here, in some sort of random. Well, if we can't have free will, we'll accept random will. That's just as good, right? The God told you, or the random God told you. Oh, there's no difference. Same thing.
This is one of the fundamental questions of quantum physics, and even Einstein had difficulty wrapping his brain around.
So again, Einstein was somehow defective because, or had some sort of psycho issue, or it was something about wrapping a brain around. No, it was just this simple objection that, I'm going with this cause and effect physical universe. Like physics, it should be something physical. Even though Einstein suggested a gravity theory that's not physical. So, he did concede he was really talking about an ether of sorts. Okay, the bent space has to be something because nothing can't bend and nothing can't move something. So, Einstein was full of shit, frankly. It was a duplicitous hypocrite. Quantum mechanics isn't allowed to be wooey, but my bent space is.
Around it. Hi, I'm Rich Burnett for Wondrium.
Who's who? Rich Burnett. I think that's the guy who owns this piece of shit. So he's I think that's the name. I'll go look. No, it's some guy, Thomas Rawlins. Whoever the hell that is. He claims to have been some student in school, and he was going to fail an exam, and he listened to some videos, and he didn't fail his exam, so he thought, oh, I'll make videos and charge people instead of making them free. Yeah. Because his course was, how to be a capitalist cunt. Yeah, well, anyway. Just, these fucking money whores pretending to be do-gooders just makes me want to vomit.
In this episode of Perspectives, three science...
So it's called Perspectives. It's Wenderum and Perspectives. It's Wenderum Perspectives. What the fuck does this mean? It's a big W and he puts the word perspectives under it. Fuck. Okay. Quantum physics explained. That's our perspective. We say so. Ugh. God, I hate this planet.
Scientists discuss groundbreaking research that led to our current understanding of the quantum world.
So all bullshit, and that's the amazing part, right? They can't use like the real experimental evidence and tell you the story. Instead, they just make up a whole bunch of fabricated crap that never took place that just validates their Holy Ghost theory. It's like it doesn't have anything to do with the truth.
We begin now, in the early 19th century, with a famous experiment that provided our earliest understanding of the true nature of light.
So this is, the true nature of light, when they're not even truly describing what the experiment actually was. It's just amazing.
Enjoy.
Ugh, yeah, it's about enjoying something. It's about telling the truth, and none of you people can do it. You're all so dishonest and for money.
What Young did...
So this is Dr. Don Lincoln of Fermilab, right? It gets a pile of government money to talk this absolute shit. Shit.
was to have two adjacent slits in a screen with another screen much further away.
So this doesn't mean anything because he's not saying what it is he's putting through the slits, So, but whatever, let's just play along.
If light is a wave, then what would happen is that it would pass through the two slits. The light...
Right, and it would create wave centers, right? So this is the part where, right away you're saying, oh, you people can't see this? The center of the wave is going to be right where the slit is. That's where the center is. That's where this is happening, this wave front. And I'm arguing wave fronts really are just like sunlight. They're really just ray fronts, okay? It's a bunch of rays coming out of the same thing, and that's what it is. It's a ray front, okay? But yes, that's what will happen in water, two waves. And the fact is if I could, I can do it over here. So, if I make these two slits, you could sit there and understand that, well, by that theory, this is the wave center here in the middle of the slit. Well, that's not the math. Obviously, it looks kind of funny. Anyway, that's not the math that actually works. The math that works is the slits, the surfaces. That's the distance you have to know to get the math correct, is you're measuring from the surfaces. They don't measure from the center where the wave should be, the center of the wave. So the whole thing is such a fraud right from the start. They can't even get the simplest parts of this right. It's abominable. Yeah, abominable.
Passing through one slit would spread out as it moves to the distant screen.
All right, so you can see right in this illustration, no double maximum, right? So the center is just as big as all the other nodes. There's no bigger center. And of course, if you're going to do this honestly, you really should be doing it on a curved screen because, frankly, you want the distance you're measuring this phenomenon at to always be the same from the place that it's originating. So that's kind of mathematically coherent, is to have the same frickin' distance. The whole thing doesn't mean anything without that, frankly.
The same thing would happen to light passing through the...
So, okay, the same thing would happen with light. So this doesn't happen with light. And it certainly doesn't happen with a real double slit. So the whole thing is such a lie. The real double slit pattern, if I can draw it on top of this without too much trouble, is going to be, first off, the center is going to be twice as big. All right, and it's going to be made out of discrete little chunks. Well, that's too many. Yeah. All right. Sorry, this is the first attempt at this. Well, actually, it's going to be bigger. So the center would be, 5 chunks, and it would expand two side nodes. And then the next nodes would be little small ones, 3s. So you'd have a 5 and 3. Or you could have a 7, okay, and 4. Or you could have a 8. Whoops, no, not always nod. A 9 and a 5. So the center is always, okay, twice as big, almost, a little less than twice as big, all right, as the rest of the nodes that'll come off and fade. So unlike waves, they're not the same amount of energy. It doesn't go here and here and here. Like a wave would say, the same energy goes to all these locations. Well, obviously that doesn't happen if you look at the actual pattern. So again, so many ways it's nothing like waves. And they're not even using the right pattern because they made these slits so tiny, okay, that they took essentially away 2 of the surfaces. And if they actually did the experiment, as I have explained multiple times, this is the complex pattern you'll get, where it has an envelope pattern and then a discrete little pattern inside. That's the actual 2-slit pattern you'll get with actual open slits, okay, with photons. With photons where slits are open more than 1 wavelength of light, which is insanely small, you're going to get this complex pattern. Nowhere to be seen in any of these wave examples. So they can't even honestly describe what the patterns actually are produced when you put actual photons into the experiment. So it's just a lie to say photons do what they're showing there. It isn't what photons do. It's just a lie, and it's certainly not what Young discovered, in the sense that Young didn't even use monochromatic light, so the whole thing was a mess. With all kinds of different frequencies bending over each other, the colors spreading.
The second screen. Since you have 2 sources of waves, these 2 sets of waves can interfere with one another.
So the real truth is, in the true double slit, it's 4 sources because there's 4 surfaces. And the 4 surfaces, basically, you're creating 2 distances. The furthest away distance between 2 surfaces and the smallest distance between 2 surfaces. The further away difference, lots of little places for a wavelength of difference. You can fit a lot of wavelengths in the base of the triangle you're going to draw. And so you get lots of little bars. And then the closest distance, very few angles where you have a full wavelength of difference, the big bars. Completely dissectable and understandable. This is entirely a surface phenomenon. The surfaces are causing the effect. This isn't about water or light bulging through an opening. All the photons aren't affected, just the ones that travel by the surface. Fact. Absolute, provable fact, and nowhere to be heard in any of this nonsense. This perspective. This perspective won't be honest to the evidence, and it won't be honest to a reasonable interpretation of the evidence. Because these lying scum. I mean, they're lying. It's not just, oh, I accidentally got all the facts wrong. You don't accidentally get all the facts wrong.
We say that the waves constructively interfere if the 2 waves enhance one another to make a bigger wave, and they destructively interfere if the 2 waves...
Right, so they say this crap, and it isn't true. Water doesn't look like the light pattern. The light creates a pattern with 1 open slit. It creates fringes, lots of fringes in light. 100 if you want. You can create 100 fringes, okay, with a single slit, with a single wave. So if you do that in water, you're not going to get any of this. It's not going to happen. You're not going to get a fringe pattern. So the whole thing is a big canard.
Cancel each other out. It takes a little math to work out where the
So the math is completely against them. The math isn't on their side. The math is clearly going to tell you that the only thing that really matters is the location of the surface. And again, for them to force a double slit to create a single slit pattern, they have to make the slits, the two surfaces, so close to each other. So they're doing a double slit experiment. And what they do is they just say, let's do this. Let's make the two surfaces that so close together there's barely any difference. So they're basically saying we're going to take 4-point sources and we're just going to make it into 2-point sources. There's just, there's just this location and this location because the two sources are so close to each other they can't produce a wavelength of difference. So they just convert a 4-surface experiment into a 2-surface or source experiment and cheat the whole thing. They end up calling a single slit pattern the double slit pattern, and it's just such a denial of the truth. It's just a lie. There's a real giant distinction between the double slit pattern and the single slit pattern. Shit.
waves would constructively and destructively interfere, which I'll skip.
So he's going to skip the math, even though it's really simple. It's just geometry. So you're just saying, here's one slit here. Okay, and you're just going to say, can I draw a line to some point? And then you're going to draw a line from this other slit and draw the line to that point. And you're going to say, is there a wavelength of difference or is there some half wavelength of difference in those lines? Half wavelength, then it's a complete off. Full wavelength, then it's a complete on. And that's all there is here. It's just an on-off pattern, basically just saying in phase, out of phase, in phase, out of phase, in phase, out of phase. That's all that's happening. 50-50 chance.
I'll just show you what it looks like. If the slits are thin,
So this isn't what it looks like. So again, the lie is it has a double maxima. Photons create twice as big a center node as all the other nodes. So this drawing is a lie. It's not what light does. Light doesn't do what water waves do. Fact.
and placed close to one another, you can treat the point between the two slits as the center, and what you see is that waves come.
So this is not a photon image. Okay, so it's not what photons do. The photons will create a center node. This center will be twice this size. Just an absolute fact. All right, and that's the single slit. And if you were doing a double slit, as pointed out, it would really be just little dots. So again, you could have 3, then 2, then 2, then 2, and then 2, and then 2, and then 2. And that's the real double slit pattern. But they won't do the real double slit pattern because they can't explain any of it. They can't explain the twice as big maxima, and then they can't explain the fact that there's two patterns. Not with a wave theory. They'd have to concede that each surface creates a wave. That's the only math that works. So when you have two slits, you have 4 surfaces, and if you do the math from 4 surfaces, then you can get the real double slit pattern, because basically when all 4 surfaces are in phase, you get a photon, and when all 4 aren't in phase, 2 are and 2 aren't, you don't get a photon. That's the truth. That's the real facts that they've obliterated with this fable, this fairy story they're placing on top of it.
Coming out at certain angles constructively interfere.
All right, we can erase. All right, continuing.
While other angles destructively interfere. You should note that there are many angles for each. So,
You should note that waves would predict the same intensity of the pattern all the way, so it shouldn't fade into nothing. It should stay quite bright for quite a good distance, because technically if you put it on an arced surface, It frankly should be just as strong this way as this way as this way as this way. So demonstrating again, nothing like a wave. That's completely against wave theory, the fact that the pattern fades into nothing. So another fact they ignore.
What would you expect to see on the distant screen? You'd expect to see bright spots where the waves add together and dark spots where they cancel. That's a clear prediction of wave theory.
So it's clearly not applicable to what photons actually do. So again, this is not a true pattern created by photons.
This is
It's not what Young saw as a fact. Young saw little round circles because of the way he did the experiment, and he saw them with the different colors overlapping. All right, but he did convert a double slit into a single slit pattern because he used really thin little tiny slits. And why did he do that, you might ask? Well, probably because when he had the slits open, right, what you would do first you do the experiment with the slits that aren't micro, that are infinitesimally small. Why would you do the experiment first by making something infinitesimally small, razor blade thin? No, you do it with big open slits. And that's when you get the very complex pattern. So he saw that very complex pattern and said, I have no hope of explaining that. So let's see if I can pervert it into something else. That's the true story. Young obviously knew of the more complex pattern. And he knew, I have no hope of using a wave theory to explain that, because water doesn't do anything like that. And so he played with the experiment until he could make it look something like water. It still didn't match, but it was closer. Because he was a wave guy right from the start. He wanted to confirm waves. He wasn't seeking the truth. He was trying to show you the ether. He was trying to prove that Jesus walked on water. He had an agenda. His agenda wasn't the truth. It was propagandizing for his pet theory.
There's a clear difference in the prediction of the behavior of what waves would do and what particles would do.
So nothing. This isn't. They aren't even fair. They don't even give particles a chance to predict. So just like when they talk about gravity, no particle theory can explain. No particle. They keep saying that shit, and they never tried to make a particle theory explain. So it's really easy to say, look, I'm not stupid. I know that atoms aren't flat. Okay, that the atoms have electrons on the outside and protons and electrons on the inside, the nucleus. So it's basically all surfaces are basically electrons first. And what I'm really doing is just sending photons, very discrete little things, through a field, and that on those surfaces they're going to plow through into a lot of those electrons and vibrate them. And that's what I'm doing. That's how I'm creating a fringe pattern, because I'm vibrating a bunch of electrons on a surface. Particles easily explain it if you give them a fair chance to. And they don't bother doing that.
So what did Young see? What he saw was a clear indication that light was acting as a wave.
So that's the big lie. The clear indication is it's not the same pattern. The photons create the double maxima. That's the first problem. And if you really open the slits, holy shit, now you got patterns all over the place. You got two patterns on top of each other. And waves ain't going to explain that. Two frickin' little waves coming out ain't going to explain two patterns superimposed on top of each other. They're not going to be able to explain the fact that this outside dimension mathematically creates one of the patterns, and the smaller dimension mathematically creates the other pattern. Their wave theory ain't going to be able to do that. That's what he saw. That's the fact. So it's all a canard, all bullshit.
There is really very, very little wiggle room.
Yeah, no, see? They just tell you that, right? Did they try to wiggle? No. Did they try to be fair to particle theory? No. Because they all wanted waves to be true. Because waves are like God. God is wavy.
From 1801, the scientific community accepted that light was a wave.
Right. They'd already wanted to, okay? So Maxwell, Lorenz, all kinds of people, they're all wave people. They're all trying to sell this crap, And so Young just added his contribution to the crap selling. And it's really just propaganda. Just like de Chardollet was trying to prove Leibniz, and she proved Leibniz with experiments that are so obviously illogical and incapable of producing a proof. And everybody's just too ignorant to figure it out because they're too busy going wave, 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 wave. That's all. They're just fans. They're not critics, and they're not honest. They're agenda. They're bandwagon riding yahoos.
However, in the late 1800s, a mystery arose involving light and electrons.
So 100 years later, amazing.
Light carries energy. You know that because, for example...
So the idea that light carries energy is a statement. And that's the bug of all this. Have you really thought about that statement even? In the sense that what is light? It's a frequency. A frequency of what? So again, the argument would be maybe it's the what, the thing that's having a frequency, that's the real carrier of the energy. And all you've done is take the energy and put it in a pattern. And that patterns are really important. Because with a pattern, I can cause an effect. So if I want to tip something over, I can't tip it over by just randomly throwing things, because the thing will bounce against the things I'm throwing, and that'll be it. I'll be destructively destroying, removing the energy as much as I'm adding energy. But if I hit it with a consistent frequency, exactly consistent with the wobble of the object, I can knock it over. And the fact is, the higher the frequency, if I just try to hit something and knock it over, if I hit it one day and it wobbles, and I come back the next day and hit it again and it wobbles, yeah, well, I'm not going to get anywhere. But if I hit it all 3 times in sequence, well, then I'm going to tip it over. So this is, this simple logic of a tipping point argument completely explains why frequency matters. But the frequency doesn't have innately more energy. It just has innately more energy to tip over a stick. You get it? I mean, 3 baseballs thrown. If I throw one today, and then I throw one tomorrow, and I throw one the next day, right? It's not going to tip over the stick. But if I throw them all 3 at once, it will. That's the only fact that's relevant. That's what gives photons energy, is that they apply energy the right way. A way consistent with disturbing an electron, causing it to gain more momentum. And if they don't hit with that frequency, they don't give the electron more momentum. And it's such a simple answer. And no, they won't even consider it. They won't even listen to this argument. I can't even pay them to listen to this argument and coherently explain how this tipping point argument isn't so much better than their silly argument and silly explanation.
Well, you can get a sunburn, which is when your skin is damaged.
Right, it's because your atoms are capable of being damaged. So again, you have to go based on what the atoms are, because some molecules won't be damaged. So you could hit titanium with a infrared, ultraviolet light all day long, and it's not going to hurt the titanium any. But yes, other chemicals it will hurt. So again, more evidence that no, you have to do a certain process to cause this problem. You have to create ions and oxidation and all kinds of other things to create the effect. So it's a subtle effect. It isn't an elemental effect. It isn't true for every single atom that if I throw a piece of infrared light, ultraviolet light at it, that all of a sudden it falls apart.
Moving to atoms, you can think of electrons as being held tightly to atomic nuclei.
So you can think of electrons being in the nucleus. So another argument that they've completely ignored. All right, so again, I could play videos from the 60s, and this is what they actually believed. They actually believed a neutron was a proton and an electron, that it was a dipole, the first smallest dipole. So they actually understood that. Rutherford actually believed that. He didn't believe in a model of the atom that said it's all protons. He believed there were electrons in the nucleus, because it made sense. It was perfectly consistent with Maxwell that electrons would be attracted to protons. There should be electrons in the nucleus because it just makes sense. And so you can have a simple argument and just say, well, protons are a little heavier than electrons. The protons don't interact with the force as much, so that's why they're all in the nucleus, is because they're harder to move, harder to knock out, and electrons are easier to keep jiggling. Simple explanation, works perfectly to understand why there's electrons on the outside of the nucleus.
In very crude terms, they're like balls tied to a post by a string.
So there's no post and there's no string. They're like magnets sitting in positions. So I could draw, I could have a bunch of north-facing magnets, let's see, and I put them between a layer of glass. And so you have, magnet, 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 and they're all repelling each other. And you could understand that, yes, that's what will happen. They'll all find a space and be comfortable. And then I could put one, south-facing one. Now, the deal would be is that, if I did that, I could understand that this one can't get closer because it's repelled by these two. And this one can't get closer because it's repelled by these two. And that whole thing, I could keep that in equilibrium. I could actually have that under the pane of glass. I could have north magnet, north magnet, north magnet, north magnet, and I could have a south magnet in the center, and they don't get pulled in because there's an equal pressure. So there's lots of ways you can balance the pressure of magnets. So the magnetic model of the atom works fine. So an atom is a nucleus, with electrons that are stuck in positions because, number one, the field is noisy, that is, they're jiggling, so they keep moving in and out of position. So the atom, the nucleus, has places that are positive and places that are negative when you look at it. And so the electron is trying to stick to the positive sections, but it can't get any closer because there's always these little electrons popping out that say you can't get any closer because I'm going to repel you. So they just get stuck in a position around the atom. And it all ends up being mathematical. You have 3 dimensions, so you have to understand you can have 2 protons here, and you can have 2 protons here. You can have them in different positions and different positions of the electrons. It all makes perfectly good sense. They've never considered any of it. They just jump to woo explanations instead. Electrons aren't real things. They don't know where they are. They're floating in Morpheus, double space. They're superimposed on top of each other and in every place in space. Blah, blah, blah. Absolute ridiculous explanations.
In that analogy, the post is the nucleus, the ball is the electron, and the string is what holds the electron to the nucleus.
So understand, the forces, the tension between the electron repulsion and the proton attraction is what's holding the electron in a position. So it's bound there, and it's jiggling all the time because it's in a giant field of active force that's constantly interacting with it. And that's the real truth of it. That's what charge explains as the universe you would see. And it's all just about hitting the electron in one direction with enough bang, 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 quickly enough to knock it from one atom to another atom and create electricity. That's what a photon does. It hits it bang, bang, bang. So it goes bang, 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 and the same electron doesn't get hit, but I don't want to go through the whole explanation of electricity and polarization and all that. But that's all the idea is that you're just taking that higher frequency, and the higher frequency just means you're adding energy to the electron before it can be stopped by the repulsive forces.
In our analogy, if you bang into the ball hard enough, you can break the string and the ball will fly away.
So that's their silly analogy. When I gave you this really simple tipping point one, that makes so much more sense, You're strafing the surface with little balls, and basically you're just basically saying, look, I hit the ball, it's got some motion, it's going to start slowing down. Well, if I hit it before it slows down, then it's going to keep going faster. And if I hit it before it slows down again a third time, then it goes even faster. And once I get going to a certain speed, it's not going to stay connected to the atom anymore. It's going to have too much momentum to be pulled back by the proton.
Similarly, if you shine a bright light on a material made of atoms, it is possible to knock off electrons. This is called the photoelectric effect, and scientists have known of this for...
So this is, you're basically pushing electrons into the surface, and you can just sort of understand that if you push them deep enough, they're going to bounce back out with a lot of momentum, a lot of velocity. And that's sort of the idea. So the quicker you hit them out of position, the more energy there's going to be to make them fly back out of that position. So it's just basically compressing a spring. And so the simple idea is if you can press the spring more, you're more likely to get a bigger bounce out. So if you're pushing an electron into a nucleus, and the nucleus has electrons in it, and those electrons are saying, I hate this, I hate this, I hate this, I hate this, and it's getting stronger and stronger. The north magnets are repelling each other, and you've compressed them into a certain tightness. You know you're going to get a high velocity out. That's all the effect is. So again, you have to hit the electron quickly to push it in close enough to create enough pressure for it to shoot out.
For nearly 2 decades before it was explained.
They didn't explain it. They offered an explanation, and it was crap compared to the simple, yeah, okay, I get it. It's a tipping point argument. The faster I hit something, the more likely it is I'm going to increase its speed. It's just even like friction. You could just argue if we were just rolling something in friction, it's going to lose all its energy. So the quicker you hit it, the more velocity total you'll be able to give it, because you won't be losing velocity to friction. The faster you go, the less friction there is. The higher the velocity you can get something up to, the further it's going to go, because it's going to lose less to friction. So the faster you can get it to go, the quickest, the more distance you're going to gain.
However, when the photoelectric effect was studied in detail, there were some mysteries, specifically 2 features.
So the study in detail is the trick. They do a couple of experiments that say one thing, and another experiment says something else, and it's all kind of a little mushy. And then they start trying to compare and say, oh, electrons are the same thing as photons, and that's just so silly. Photons aren't charged. Electrons are. Of course they're going to behave different in different circumstances. It's just ridiculous to say they could ever behave the same.
The first is puzzling. Certain colors of light will knock out electrons and others won't. The exact color depends on the substance, but roughly speaking, red, orange, yellow, and green.
So we're talking about how big the atoms are, so the substance argument. So you could basically argue that the bigger the atom is, the more distance the electron has to travel. You could argue that it's harder to compress when it's a big atom than it is when it's a small atom. It depends, all kinds of variables like that. And so obviously each material says it's a different wavelength at which I'm going to start pushing electrons off. You'll start knocking electrons off the surface. That's the point. But most metals do it at a pretty consistent rate. But you would say that it's like copper could be here and iron would be here, where the starting number is, what frequency you need before before you can start giving the electrons enough momentum to leave the surface.
Just won't do it. Blue, purple, and ultraviolet will. Even at the time, physicists knew that different colors had different wavelengths, with the red, orange, and yellow side having a long wavelength. And
all right, we know it's a frequency. So again, they shouldn't even be talking about a wavelength in this circumstance, because all we're talking about is a frequency. How fast are you hitting it? And that's the obvious answer. That's the obvious feature that's different between the red and the blue, is how quickly are you imposing the frequency, the happening, the event of the lump. And how many lumps does it take, right? They never draw this like a photon is 5 lumps, a photon is 25 lumps. How many lumps is a photon? They don't show you any of that. They have no coherent argument to make about what a photon is even made out of or how it gets from here to there. And then they deny what is so obvious, that obviously photons travel in dead straight lines. I mean, we can collect one from billions of light years away, one single little photon, we collect it.
Blue, indigo, and violet side having a short wavelength. And each material had a specific wavelength above which electrons would not be emitted and below which they would.
And then for the other effect, which is the other photoelectric effect, right? Okay, this is the photoelectron effect. They really should just describe them two different ways. And the other one is just causing electricity in a surface. And you can do that with much lower frequencies. Because what you're really just saying is you're going to push an electron. Instead of pushing it off the surface, you're just going to sit there and push electrons faster and faster. And they're fast enough where they'll hop from one atom to the next and force an electron to move. So essentially you're going to move an electron in the surface versus shooting it off the surface. So there are two different effects and very similar causes. That's just how much momentum can you give an electron. So lots of materials will create electricity on the surface, but only certain materials will be able to launch electrons.
So that was a bit weird, but it was compounded by the fact that it didn't matter how bright the light was that you used. The wavelength thing was the barrier.
So again, this word bright is, how many photons, and so that's clearly, you have to understand that's how the universe works. It's about how many of them, okay, not some amplitude of their wave or some other kind of nonsense. It's how many. How many rays of a frequency of bits is the truth of it.
Use really super bright red light and you get no electron emission.
All right, so they have redone this, and they actually can create some effect with a strong enough infrared source. So they can make infrared do it, and the argument could be made that yes, very improbably, you hit the surface at just the right time with the two infrared photons, and the two photons end up behaving, two infrared photons end up behaving like an ultraviolet photon. So if I took two, I could draw it here, I suppose, maybe. Can you see that? No. I'll draw it up here. So if infrared light was this kind of spacing, you can understand I could add two of those out of phase, and I'd end up with, the ultraviolet frequency. So that is something that's possible, but it only happens rarely that the photons hit exactly at the right polarization, that is the right spread across the surface. So when they hit it the right spread across the surface, you can convert two infrared photons into an ultraviolet photon. Would be, I think, a reasonable guess. And that's all. Most of this is just guessing. All right, consistent with the evidence. And I'm just saying it does fit the evidence. It is a viable theory. I'm not asserting it's the absolute truth, but I'm just saying it does explain why you can force some effect with enough volume of infrared photons.
But use weak purple light and voila, electron emission. And if you turned up the brightness of purple light, you'd get more emission. Now, if light is a wave...
And if you use X-rays, you get even more. And if you use gamma rays, you get even more. So the idea is the smaller the frequency, the tinier and tinier the distance between the events, the more likely is that you're going to convey this high velocity. So the faster you can hit something to push it, the quicker you can impose the energy, the faster your initial velocity, and therefore the further your complete travel.
Wave, that's a weird thing, because the energy of a wave depends on what physicists call its amplitude.
So again, it just doesn't mean anything. They're not really talking. Amplitude is always going to be about the number of waves. It's just, there's no such thing as increasing the amplitude of a photon. So it's just silly. It doesn't suit wave mechanics at all, because you're just not making one signal bigger. You have to make it bigger by having more little individual signals. That's what the facts scream as the truth.
Or, colloquially, its brightness. It's kind of like waves on the beach. Little wavelets don't do much damage, But get a 6-foot tall wave and they'll knock you on your keys.
Right, so obviously this isn't about making a 6-foot tall single photon. It's about making a bunch of photons coming at the same time. So, the fact is you can't do a water analogy unless you have a whole bunch of different sources of water and have little waves on them. And then you could say, oh yeah, there's more amplitude hitting the surface because you have more sources. So if I make waves from a lot of locations in the water, so I'm out in the water and I'm going to make waves, and I'm going to make it with a lot of sources, well, all the sources will add up. Even though they're all at a high frequency, I'll increase the amplitude at that high frequency. So I can create that, but I have to have more sources to create a higher amount.
Sure. And tsunamis with really high waves will knock over buildings. The height or amplitude of the wave governs its energy. So that's a weird thing.
No, it's just baby talk. It's a weird thing. Okay, so it really has nothing to do with the subject, frankly. It's just obvious, more sources if you're going to use a frequency of wave, and that's just your obligation.
It means that in the photoelectric case anyway, light isn't acting like a wave.
It's clear it's not acting like a wave in any case if you're really fair to the argument. Again, it's the surfaces that are creating the double slit pattern in light. And it's clearly the surfaces. The math explicitly says use the surfaces to define your point sources and you'll get a right answer. Use the wave centers, the supposed wave centers, and you'll get a wrong answer.
The situation was resolved in 1905 by none other than Albert Einstein. Einstein proposed...
So the resolution really doesn't get to a complete answer. So it's a 3-paragraph paper. It's really not enough detail to really get to the point. So he uses words like light quanta, which could mean either way. Either the photon is made out of individual bits of quanta coming at a frequency, and maybe that's what he was trying to describe, or it could mean that each photon, in the case of radio waves, is 10 miles long. There's some kind of quanta that's 10 miles long. So I think the obvious answer is no, there's little tiny bits of quanta, and you can have a 10-mile distance at the speed of light between two little tiny discrete bits of energy. That makes about 1,000,000 times more sense. So understanding it as little discrete blocks at a certain distance, little baseballs at a distance, and saying that's the frequency, that's what the light is. So a photon is, say, 3 of those things hitting a surface. Bang, bang, bang. Or ultraviolet light, bang, bang, bang. Unfortunately, his paper doesn't have any details in it, so it's not very useful, frankly. It's only useful for the single purpose of saying it looks clumpy. Well, if you want somebody to explain to you that it looks clumpy, fine. Again, this goes back to Feynman. Feynman was quite emphatic. What the hell word is that? I'll pause. Emphatic. Yeah, that's it. Quite emphatic in pointing out that I wish they didn't teach waves because it's clumps, but his argument failed in a sense that he was saying, look, only a clump detector can detect it. Well, that's the whole point. You're using a clump detector, so of course it looks like clumps, but you're using a clump detector. So as much as I like that Feynman's saying it's not a wave, I hate that he's using a pretty poor example of why it's not a wave, because it's not about the detector. That's not telling you what a photon is, because you're detecting it with something that can only detect clumps. Obviously, it's going to look like it's just clumps then.
That light came in discrete lumps, which is a fancy way to say in particle form.
Look, they used the word corpuscle back in Newton's day, and I think Einstein actually reused that word. And then he said energy, light quanta. So he's not saying what I would have said, which is bits of energy, okay, at a frequency. That's the simple explanation. It's bits of energy at a frequency. Baseballs at a frequency.
The energy of each lump was proportional to the frequency of light. Frequency.
So again, this energy argument is just basically saying how do you affect something doesn't mean you have more absolute energy. It just means that it's able to absorb the energy more efficiently. So if you want to absorb energy, you have a pendulum swinging and you decide to throw something at it when it's going against the motion. Well, you're going to take energy out of the pendulum. Does it mean that you didn't throw it with the same energy? So I throw it when it's going with it and I add energy. Okay, and it looks pretty impressive because I added energy and it's really swinging. And I throw it when it's against and it diminishes the amount of energy. Does it mean this interaction had less energy? No, it's just circumstantial. You're just saying, yes, when you're adding energy, it's going to, it's going to look like a lot of energy. When you're subtracting energy, it's not going to look like a lot of energy. I mean, it's the same energy. All the photons have the same energy. They just apply the energy in different amounts of time, and if you shorten the distance in time that you apply energy, you can break things. I mean, this should be so elemental and so obvious to physics that it's not about applying heat to a piece of glass. I could apply heat, thousands of watts of heat, and as long as I apply it evenly over the surface, the glass says thank you very much. But if I apply it in one little spot, the glass breaks. That's what this is about. It's not about how much energy, it's about how you're applying the energy.
It's inversely proportional to wavelength. So a long wavelength wave has a low frequency, while a short wavelength light has a high frequency. Thus, the light on the blue, indigo, violet light was high frequency, which, according to Einstein, meant high energy.
So it doesn't mean high energy, it just means high likelihood of adding energy to a system. It has a high likelihood of creating more momentum in something, and more momentum means you'll travel further because friction is less effective against you. So that's sort of the fact. You'll go much further before you run out of distance. You'll gain greater distance by applying the energy quickly than applying the energy slowly.
Also, let's think about what it means and how the particle idea explains the data. If light is a particle and the energy of the light is proportional to the frequency, then below some frequency, the individual particles of light, what we call photons, just don't have enough energy to knock out an electron.
So this is the part, again, where I think, just a little bit of a logic applied and you could understand it's not about the frequency in terms of its energy. It's about taking advantage of how you break things. You need to apply the energy in a certain way to break it. Apply the energy differently and it won't break.
Getting back to the analogy of a post, ball, and string, if you throw an object at the ball and it doesn't have enough energy, it won't break the string.
So again, you could use a tether ball as an example. It's spinning and you have to apply the energy at just right. And if you apply it a little bit too late, well, then you don't push the ball much. You hit it too early, then you push the ball in the wrong way. You got to hit it just right to add maximum amount of energy. So it's just about how you apply the energy. It's not about how much energy, it's about how you apply the energy.
Any photon with higher frequency, which is to say higher energy, will be able to do so. So you can perhaps see why Einstein's idea was so powerful. In fact, it was...
So again, there was nothing, in my opinion, it's not very powerful beyond just saying, well, look, it does in every appearance, to really answer this question, comes in clumps. There's no variable photon. I can't make a weak photon and a strong photon. I can only make one kind of photon.
His explanation of the photoelectric effect that netted him the Nobel Prize in Physics. It wasn't relativity. All right, now we're in a pickle. Thomas Young proved quite convincingly.
So Thomas Young proved, so he didn't do that. It didn't happen. Not a real event. It didn't happen. It's not the truth. He didn't he didn't create any evidence that wasn't easily explained by a particle model.
That light is a wave.
So it just didn't happen.
Well, Einstein just as convincingly showed that light was a
So
particle.
why didn't you just say prove, okay, instead of just convincingly? No, he proved, okay? So you're just saying two people prove completely contradictory theories, and instead of recognizing that, well, that's bullshit, it can't really exist as both, so let's try to find a better answer. And instead they decide to say, no, that somehow in some experiments it's particles, and in some other experiments it's waving. I mean, it's just absolute nonsense.
Light can't be both a wave and a particle, can it?
No, it can't, and you're just idiots. Frankly, you're idiots to sit there and try to contrive nonsense to make that possible. It can't be that it does both things. It's one or the other. There's the medium, and the photon is some wooey thing in the medium, or you could understand that there's a real substance in the universe. It's not an ether, it's a bunch of bits of energy quanta, and if you throw them at a frequency, they can make shit happen.
And this gets even weirder. If Einstein is right, how can we explain the Young double-slit experiment?
It doesn't take much effort at all. You just first recognize the surfaces are the thing causing the effect, and it's proven by your own mathematics. The math absolutely proves the surfaces are they're just point sources. Or the wave centers are the surfaces. The wave centers aren't the opening. The wave center is on the surface. That math will always get a right answer.
To take another look at the Young experiment, researchers tried a variant of it. They started by just reproducing Young's interference result. Nothing had changed in the intervening century. But then they turned down the intensity of the light.
So this is a fake experiment, all right. So, it's a whole nother subject, okay. So Veritasium did this experiment, and he couldn't get it to work. So you do a nice time lapse, right? You take 40 days is how it was originally done. And you put a very, very dull source of light. And then you have your two slits, and then you see if the pattern can be created with the dull source of light, where there's very few photons in the experiment. And the original experiment was over, like I said, over a month. And the fact is, you still got a fringe pattern, indicating that single photons were making the event happen. Now, the trick is that there's no way to make a single photon. There's no engine that can make a single photon. So they're making single photons by basically putting a bunch of slit experiments in front of the photons. So they were basically saying, look, we're going to put dirty glass in front of the light source, until we almost stop every single incident of photon getting through. And all they were doing is creating a bunch of surfaces that kept breaking the photons into pieces. So now they're just throwing pieces of a photon at a surface. So, that's all the experiment it turned out to be, is that there's no single photons. They were just basically saying, let's make even more pieces, and then when one of them shows up as a real photon, it'll be an event. But they're still throwing enough photons at the slits to create a fact that there has to be a photon at both surfaces for there to be constructive interference, as they call it. For them to be in phase, there has to be one at each surface, and if you don't have one at each surface, you're not going to get a photon. So clearly there's still more than one photon at a time in the experiment. So anyway, Veritasium tried doing it the long way, like over 12 hours. Couldn't get the experiment to work. What did he end up doing? 5 minutes. So he ended up taking an experiment that's supposed to be done over a long period of time, and he cut it to 5 minutes. And why did it work when he did it at 5 minutes? Because obviously there was a lot more photons in the experiment. Same number of photons over 12 hours versus same number of photons over 5 minutes. Obviously more photons in the experiment.
So low that only one photon was emitted at a time.
So there's no evidence that this has ever taken place in the history of mankind, that they ever create a circumstance where one photon was in the field at a time. No evidence.
And they shot the light at a pair of slits and looked for the photon on the distant screen.
The photon is an event that happens at a surface. So that's the other thing you have to understand. The photon happens at the surface. And so in the slit experiment, you're basically sending information from one source and sending it from the other source, and the combination of that information becomes the photon. So the photon doesn't exist coming from this place, and the photon doesn't exist coming from this place. And it's only when both of them hit this surface at the right time that you have a photon. So there's no photon traveling here and photon traveling here. There's pieces traveling here and pieces traveling here, and they hit the surface just the right way to duplicate a photon.
Let's talk for a moment about what you would expect for both the particle and wave scenario. If light is a particle, it would appear at a specific spot on the screen like a bullet hitting a wall.
So again, even Einstein isn't saying, I don't think, that light is a particle. He's saying it's made of particles. Because then you still have to believe that Einstein thought there was a 10-mile long particle. And he didn't think there was a 10-mile long particle. I don't think. You know, for radio waves, for example. He wouldn't think there's a 10-mile long particle. So it's just sort of cheating the argument. So the fact is that you're sending a group of particles, and the fact is you're looking for them to hit the surface in a sequence, and that will be a photon. But regardless, let's just play with this silly. This is just the silly argument that when if I put a second slit, what's going to happen? And this the simple truth, if I put a second slit, all right, I'm going to end up with a very nuanced and complex pattern.
If light is a wave, it would appear in the wave pattern, just very, very faint.
So we know water waves in the single slit doesn't create any fringe pattern. So again, it's just a lie to say it does, it doesn't. So it doesn't happen. Single slits don't create. So he's got two waves here again. So he's showing us a particle going through one slit, and then he shows us a double slit pattern. And it's not a double slit because he's got the wave centers on the center of the slit, so he's not using the surfaces. So it's just bullshit.
Then photon after photon, the pattern would get brighter and brighter.
So here they're showing the pattern is to look, it looks bigger in the center now, and so it's all, they just make this shit up. Water doesn't do that. Okay, it doesn't happen. It doesn't create a double maxima.
Later. So what did they see? They shot the first photon, and it turned out, a drum roll please, it appeared as a single spot.
So this is just recreating the pattern with very dim, broken light. So the argument is you're taking a bunch of pieces and throwing them through the slits, and you're just basically saying, yeah, I'll just be able to do exactly what I just said. I'll take pieces from one slit and pieces from the other slit, and those two will end up in the same location. And let's understand these two slits are so close together that they're only going to create a single slit pattern. And again, he's not going to draw it correctly. I mean, the single slit pattern, again, has the double maxima. The center is twice as big. It won't be shown that way.
It was like a particle. But that's just totally weird, since a bright light on two slits resulted in Thomas Young's wave pattern.
So, again, the double slit pattern, even with, creating a single slit pattern with a double slit pattern, you're still going to have a double maxima. So there's no accounting for the fact that there's no double maxima here. There's no twice as big thing in the center. And again, this fading going off the sides, again, clearly not wave behavior. Waves say each one of these bars should be the same intensity. That's what waves say should happen. It's not happening, obviously. Obviously not consistent with waves.
So they continued their experiment, and they shot a second photon. Still detected like a particle. Okay, then another and another and another. Let's just fast forward and see what the final result was. After millions and billions of photons, what they found was the wave pattern.
So you can't really, this is an experiment you really have to be able to detect what slit it went through. So now we have very precise lasers. They could really do this experiment. They could really just shoot light through one slit and then through the other slit, then through one slit, then through the other slit. So that's the big fraud here, is they could do that now and they don't bother. And this won't be revealed. The fact is you have to have both slits receiving energy for there to be a fringe. The fringes are created they are explicitly, the math says so. You have to have both sources.
It's Fahrenheit. This is a significant difference.
Yeah, that's not the right video.
Nobody believed me at first,
Shut up.
but now
Stop. Yeah, not interested.
Of the double slit experiment.
I wonder which way electrons behave.
Okay, so they switch presenters, and this is the biggest fake lie crap. So this is Feynman's description of a make-believe experiment never actually ever conducted. So it's just such a canard to imply they actually did this experiment and actually got these results. So this is Dr. Quantum bullshit, complete lie science. And here it is presented as this is what great thinkers do. This is what you do if you're going to do something greatly, is just make up complete fables, complete fake experiments, never conducted, never happened, and use it as evidence. Here, look, we proved it with this completely fake experiment. It's like just making a fake picture of Jesus walking on water and just showing up and showing the fake picture and saying, see, look, he's walking on water. Okay, yeah, it wasn't really Jesus. We just took a guy from Mexico called Jesus, you know. It's Jesus walking on the water. Fuck. Fuck. All right, so where am I? Yeah, okay, maybe I'll make it 2 videos then. Or 3. Yeah, so we did the doctor link, and this, I don't know who she is, Miss Propaganda. She doesn't seem very famous or anything, but whatever. This is such a lie. I mean, it's just so bad. So, you know, Lincoln was bad enough. This is going to be worse. That's how it's that bad. And this is what they're presenting as why we believe in quantum mechanics, is they're just founding it on all these lies. And they're lies. Like I said, this isn't a mistake. You know, this isn't that hard to research. These experiments aren't that hard to do. Seeing the difference between the true double slit pattern and the single slit pattern and what water does, it's pretty easy to do that and see that, yeah, there really isn't any connection. Water really doesn't act like photons. It really doesn't happen. All right, so enough of a video. Till the next time and such. Abysmal. Yeah, just it's horrible. Hate this planet of... Frankly, I mean, there's nothing else that you can't say anything. A planet of liars. They're just the way it is. Everybody is so ungenuine and so agenda whored. It's disgusting.